Are you hungry? Here, have the sandwich. You gotta like a cinnamon roll. What? How about a sandwich? Okay, how about a healthy choice? I bet you're gonna like banana.
Bridget, what are you doing?
I'm trying to feed the Venus flytrap.
What's it called?
A Venus flytrap.
Say that again.
Venus flytrap. Oh, I don't have any flies for you.
Cut!
Hey everyone, Bridget here at Como Park Zoo and Conservatory. Today we are going to be asking some questions about how plants and animals get their energy. What ways have they adapted to catch and eat their food? What physical and behavioral adaptations have they evolved to do this efficiently? We'll be answering all these questions as we look into the adaptations that plants and animals have to catch and eat their food. I'm here with the Venus flytrap. What's one of the first things you notice when you look at this plant? One of the first things I notice is its leaves and its tooth-like structures, which is where it gets its name. Venus flytraps have evolved to eat bugs because of the low nutrient soil they grow in. A flytrap has very sensitive hairs on the inside of their leaves called trigger hairs. These hairs will let the flytrap know if there's a bug in its trap. The crazy thing is, the flytrap can count. A bug has to wiggle at least 3 times in order for the flytrap to close around it. The reason for this is it takes a lot of energy for the flytrap to close. If a piece of dust or leaf happened to fall in the trap, it could waste its energy closing around something that isn't food. The adaptation to wait to close until there is for sure a bug wiggling in its trap is how the flytrap efficiently catches its food and saves energy. Once the flytrap closes around the bug, the plant starts releasing its digestive juices, similar to what you have in your stomach, and that helps the plant break down and absorb the bug.
But Bridget, what are some myths about the Venus flytrap?
It can bite you and it will make you bleed. The tooth-like structures on the flytrap leaves are called cilia. They are stem-like parts that are meant to trap insects that come into the trap. They are not sharp and cannot hurt you. If you stick your finger in a Venus flytrap, nothing is going to happen. It can eat humans or even animals. Venus flytraps are quite small. The largest their leaves grow is about 2 inches, so they can't grow large enough to eat animals or humans. Man, I'm glad these teeth aren't sharp. Let's go look at our next animal that's got its reputation from having pretty big teeth, or fangs.
Snakes!
Let's break down snakes by category based on how they catch and kill their prey. Venomous snakes inject venom into their prey via their fangs. This group includes vipers, cobras, and rattlesnakes. Constrictors are snakes that use their body to squeeze their prey until dead. All snakes will swallow their prey whole. We are going to get to witness something you rarely get to see as a Como Zoo visitor. We are about to see a snake feeding. I'm here with zookeeper Allison, who cares for many of the snakes here at Como Zoo. Allison, who are we going to get to see eat today?
We're going to be feeding Nadira. She's one of our ball pythons here, and we are going to be feeding her a weaned rat. So it's a smaller rat, a young rat.
And when was the last time that she ate?
She ate 2 weeks ago.
Whoa, 2 weeks ago? I don't think I could eat every 2 weeks.
Me
I
neither.
need to eat my 3 meals a day.
Same.
And why is it that you feed not alive rats and mice instead of live rats and mice?
Good question. We don't feed live mice and rats because there is a possibility that if the snake doesn't eat them right away, they could get injured from the rat. So just to be safe, we like to feed the frozen thawed.
All right, let's go feed a snake. Wow, that was quick. In case you missed it, let's go see a few others. All snakes have teeth, though, like we learned before, not all of them have venom in their teeth. Constrictors, like the one we're watching now, have teeth they use to bite and grip their prey. The teeth are tiny and point backwards towards their throat. The teeth also help them swallow their prey whole. These snakes are going to take a while to eat. So we can observe the whole process, let's watch a snake eating on camera. So how do snakes swallow such large meals? Snakes have very specialized skulls and jaws. Their jaw bones do not connect at the base of their chin. Instead, they're connected with ligaments. This allows them to open their jaws horizontally as well as vertically. Their jaw bones can also move independently of one another, which is how they can get their food down their throat. The general rule is that the snake can eat something as big as the widest part of their body. Because snakes are cold-blooded, they have a slower metabolism. Since they don't generate their own body heat and instead seek out heat from a source like the sun, they don't have to eat as much or as often as a warm-blooded creature that has to make its own body heat. Most medium-sized snakes eat only every other week. Larger snakes, like the anaconda, eat as often as once a month, but can sometimes go without food for an entire year. I'm here in Como's Tropical Encounters Rainforest exhibit, where you can see that there's some large animals swimming behind me. These are fish called pacu. They're native to the Amazon rainforest river basin. One kind of weird adaptation that pacu have is their teeth. Pacu have teeth specifically for cracking open and eating nuts that fall into the Amazon River. If you look at the jaws of a pacu, you may notice that their teeth look similar to our human teeth, molars and all. And unlike their cousins, the piranha, who eat meat, the pacu are plant eaters. We're gonna get to see the pacu's teeth in action. I'm here with zookeeper Blake. Blake, what are the pacu gonna be eating today?
Oh, we have lots of great stuff today. So we're gonna be feeding some lake smelt, one of their favorites. We also have some chopped fruit and veggies. So I have some cucumber right here. I have some pieces of potato. I think I even have a couple grapes. And then also one of their favorites is I have some gelatin diet. We make it the same way as you make Jell-O at home. Doesn't taste nearly as good.
Delicious.
Wow, that was great. Let's go see our next animal that doesn't even use teeth to eat. Where is it? Where is it? Where is it? Oh, there you are. This is one of Como's veiled chameleons. We have 4 veiled chameleons here, and chameleons, as you might know, have a very interesting way of eating. Let's go see it in action. Chameleons have a great adaptation for eating, and it's all in their tongue. If you've ever seen a chameleon catch its prey, you know that their tongue acts like a slingshot. This is all possible from a special adaptation called the hyoid bone. With this bone and help from surrounding muscles, the chameleon is able to launch its tongue out at record speed. A chameleon's tongue can go from 0 to 60 miles per hour in 1/100th of a second. That's 280 times faster than the fastest car. Many mammals, including humans, have a hyoid bone. It helps with carrying the weight of your tongue, helps you swallow, and even helps you talk. A chameleon's tongue is twice the length of its body. To a human, that would be a 12-foot-long tongue. A myth about chameleons is that they change colors to blend in with their backgrounds. The main reason for a chameleon's color change is to reflect their moods. They can send social signals to other chameleons. Darker or brighter colors oftentimes mean the chameleon is angry or upset. Lighter, softer colors tend to mean the chameleon is calm or neutral, or trying to attract a mate. Color change also may have to do with their body temperature. Wow, that was cool. Our next animals we are going to see eating don't even have tongues. Our next adaptation for eating is a peculiar one. I'm here with Como's new sea star and anemone tank. How do sea stars and anemones eat their food? Let's find out. With sea stars, they digest their food outside of their body by projecting their stomach out through their mouth and enveloping their whole meal. Anemones have stinging tentacles that shoot out tiny harpoons that paralyze prey. They then bring their prey to their mouths where digestion takes place inside their body. Wow, those are some really cool physical adaptations for eating food. Let's go see an animal that uses more of a behavioral adaptation. One behavioral adaptation that's very helpful to many animals is the act of caching. Caching is storing food to be eaten at a later time. And we have one of the masters of caching here at Como Zoo, which is the Arctic fox. By storing food, the Arctic fox has meals to last all winter. The most common foods these little hoarders will store are things like goose eggs, lemmings, and goslings. The foxes will rely on these meals as backup in times of food shortages in the Arctic. This is an environment where the amount of food changes dramatically between the seasons and the years. But you don't have to go all the way to the Arctic to see this behavior. You can find it in your backyard or local park with squirrels and chipmunks. Something we have plenty of here at Como. Chipmunks can gather enough food to last them an entire winter in just 2 days, which is about 165 acorns in a day. A squirrel can fit up to 2 acorns in its mouth. A chipmunk can fit up to 12. Squirrels are able to recover 84% of the nuts they cache. Some squirrels, like red squirrels, store their food in a central location called a midden. This is known as larder hoarding. Gray squirrels have a great memory and rely on their sense of smell to recover their cached nuts. This is known as scatter hoarding, or spreading their nuts around all different places. You can see these behaviors taking place in the fall here in Minnesota as squirrels and chipmunks are caching their foods for winter.
Bridget, what are you doing?
I'm using a human adaptation for eating. Now let me eat my lunch. See you guys next time.